Good morning everyone. This is Sumanna, Assistant Professor of Biochemistry. Today's our topic is interaction between enzyme and the substrate. Why there is the need of interaction between the enzyme and substrate? See, what is the main function of the enzyme? It will catalyze the reaction. So, there is the for the formation of the product, first the enzyme and substrate should get interact or should get bind. So how this interaction will occur, we'll discuss. The prime requisite for the enzyme catalysis is that the substrate must combine with the enzyme at the active site to form enzyme substrate complex, which ultimately results in the product formation. See, the enzyme and the substrate are getting combining to form the enzyme substrate complex. Then this substrate is converting into the product and the enzyme in its original form is relieving so that it will be available for the other substrate molecule to get bind. So how this interaction will occurs between the enzyme and substrate will be explained by the two theories. A few theories have been put forth to explain mechanism of enzyme substrate complex. That is, first one is lock and key model, or it is also called Fisher's template theory, and the second model is induced fit theory or Koshland's model. These two theories put forward to explain the interaction between the enzyme and the substrate. First is the lock and key model, which is also called Fisher's template theory. Why it is called Fisher's template theory is because it is proposed by the scientist Fisher. This theory was proposed by a German biochemist. His name is Emil Fischer. That's why it is called Fisher's template theory. This is in fact the very first model proposed to explain enzyme catalyzed reaction. This is the first theory which explains the enzyme catalyzed reaction. And according to this model, the structure or conformation of the enzyme is rigid. Here enzyme is rigid means that is active site. See, this is the enzyme and this will be the active site. This active site is rigid. Rigid means it is not flexible. It is a preformed structure, like it may be in this form or in this form or in this form. It is rigid. It is cannot be flexible. It cannot change its shape. That is nothing but active site. Active site cannot change its shape and it is rigid. And the substrate fits to the binding site, that is active site, just as a key fits in the proper lock or a hand into the proper glove. See, why it is called lock and key model is, like lock is like enzyme and key is the substrate. Only one key can be fitted in one lock. The other key cannot fitted in one lock. So the substrate and enzyme, the active site of the enzyme is rigid so that only the particular substrate can bind at the active site of the enzyme. In this way, he explained that lock and key model. Lock is enzyme is like lock and substrate is like key. That key can be fitted in a particular lock only. And the active site of an enzyme is a rigid and pre-shaped template. That's why it is called Fisher's template theory, where only a specific substrate can bind. And this model does not give any scope for the flexible nature of enzymes. Actually, the enzymes are flexible in nature. According to the shape of the structure, the active site of the enzyme will be changed. So, this model is saying that the active site is rigid. Hence, the model totally fails to explain many facts of the enzymatic reactions, and the most important being the effect of the allosteric modulators. It's failed to explain the many enzymatic reactions, particularly the most important one is the allosteric modulators. So this theory is get failed. Lock and key model or Fisher's template theory is failed because he said that the active site of the enzyme is rigid. And the other model is induced fit theory or Koshland's model. Why it is called Koshland means the scientist Koshland proposed this theory. That's why it is called Koshland's model. Koshland in 1958 proposed a more acceptable and the realistic model for the enzyme substrate complex formation. And as per this model, the active site is not rigid and pre-shaped. The active site is not rigid or it's free-shaped. Moreover, and the essential feature of the substrate binding site, that is the active site, are present at the nascent active site. Okay, the essential features of the substrate binding site are present at the nascent active site, and the interaction of the substrate with the enzyme induces a fit or a conformation change in the enzyme, resulting in the formation of a strong substrate binding site. So there is no preformed or pre-shaped active site, and like the active site may be like this, and we suppose the enzyme, the substrate is like this active site will be converted into this way. Okay, so according to the shape of the substrate, the flexible active site will be formed or changed to bind with the substrate molecule. And due to the induced fit, why it is called induced fit means it is nascent active site, because of the substrate it is getting induced to fit the substrate. That's why it is called induced fit theory, and it is proposed by Koshland. That's why it is called Koshland's model. Due to the induced fit, the appropriate amino acids of the enzyme are repositioned to form the active site and bring about the catalysis. How the flexible nature of the active site is that it's because of the repositioning of the amino acids to form the active site. And the induced fit model has sufficient experimental evidence from the X-ray diffraction studies. With the X-ray diffraction studies, it is confirmed that the active site is not pre-shaped or rigid. It is flexible according to the shape of the substrate. It is getting induced to fit the substrate molecule. And the Koshland model also explains the action of the allosteric modulators and competitive inhibition on enzymes. See, here you can see in the diagram, see this is the substrate. It is, and in the lock and key model, the active site is pre-shaped. It is rigid, and according to the substrate molecule, the only specific substrate can bind with the enzyme molecule. See, you can see here, this is the enzyme substrate complex. The active site is pre-shaped and rigid. The substrate is coming and binding in these grooves or pockets, like key is in the fit. So that's why it is called lock and key model. And when it comes to the induced fit model, the active site is not pre-shaped, it is flexible, and this according to the substrate shape, this active site is converting into this way according to the substrate molecule. That's why it is called induced fit. Why induced? It is inducing or changing. Fit means to fit the substrate. So induced fit model is the accepted theory to explain about the interaction between the enzyme and the substrate molecules. And the lock and key model is got failed because showing that active site is the rigid. Because of rigid structure, the substrate cannot bind with the according to the substrate molecule to the active site of the enzyme. And thank you to all.